Third lesson in Unit 5 on rate of change and slope. Your learning targets for this lesson is to be able to identify and define dependent and independent variables, to find the rate of change, and to find the slope of a line. A rate of change is a ratio that compares the change in a dependent variable y with the change in an independent variable x. We can write that rate of change in this way, where we have the change in the dependent variable on the top and the change in the independent variable on the bottom. So let's look at an example. Here's a table with some fees for canoe rentals. Our first part says to identify the dependent and independent variables. So does cost depend on the number of hours of rental, or do the number of hours of rental depend on the cost? Well, as we've discussed before, time is almost always the independent variable, and the cost depends on the number of hours that you rent the canoe. So when we want to find the rate of change for the rental fees, we need to find what that change is for each of these variables. So when we look at the time, we're going from 3 hours to 6 hours, and then from 6 hours to 9 hours. So each of these is going up by 3. So the amount of change in our independent variable is 3. The change in our dependent variable, if you look at how we arrive from the first one to the second one, we would subtract those, and you would find that it's going up by exactly 15 in both cases. So then we would end up with a change in the dependent variable of 15 and the independent variable of 3. So what is the rate of change? The rate of change is $15 divided by 3 hours, or $5 per hour. And that is representative of what the rate is for the canoe rental. It's $5 per hour. The slope of a line is a rate of change, just like we just discussed. That's all we're talking about when we talk about the slope of a line. The slope is the slantedness of a line, and it's just a rate of change. It's a ratio of the vertical change, which we call the rise, to the horizontal change, which we call the run, and you can find it between any 2 points that are on a line. So here are some examples. Find the slope of the line. In example A right here, I have some green dots on the line. And to find the slope of that line, all we want to do is write the vertical change divided by the horizontal change. So the vertical change I go up 2, so it's plus 2, divided by, and then I could go to the right one. If I start at 0, 0, I go up 2 and right 1. And those are both positive directions. Up and to the right are both positive directions. So our slope for this example is positive 2. Example B has a different kind of slope. So this one I'm going to identify as a positive slope over here. And this one will be a negative slope on the right. So on the right-hand side, again, I have some green dots. So pick any dot where you want to start. To get from one dot to the next, I'm going to go down 3 units and then right 2 units. So my slope on this one, my vertical change is negative 3 divided by a positive 2, which is equal to negative 3 halves, or negative 1.5. We will usually leave our slope as improper fractions with whole numbers rather than decimals. It's going to be a lot easier to work with the fractions than the decimals. So horizontal and vertical lines. The graph of the equation y equals c, where c is just a number. It's a constant. So we don't have an x variable. We just have like y equals 7. This is called a horizontal line. Its slope is equal to 0. So that's going to represent the graph on the left. The graph of the equation x equals c, where c is a constant, again, it's just a number, is a vertical line. Its slope is undefined. And that one looks like this one. So we have horizontal lines, y equal to a number. Vertical lines are x equal to a number. And you're going to need to memorize those so you can tell them apart. So this one is x equals c. And then over on the left-hand side, you have y equals c. So this example right here, I have y equals 4. This example on the right, I actually have the equation as x equals negative, how many is that? 1, 2, 3, 4, 5, 6, 7 maybe? Negative 7. Those are the equations of the lines that are shown. So let's take a look at what we know already. Determine whether each pair of points lies on a horizontal or vertical line, then find the slope. Well, I have one point already plotted here. 5, 1 is plotted. If we plot 8, 1, remember we start at the origin, go over 8 units, 6, 7, 8, and up 1. And if we were to connect those two dots, that would definitely represent a horizontal line. So the one on the left is a horizontal line. The slope then for the one on the left, you'll need to memorize this as well. Slope is equal to 0. All horizontal lines have a slope of 0. On the right-hand side, I have the point 3, 1 already plotted. So then if I plot 3, 9, I'm going to be up here. And you can see that this will be a vertical line right there. So if we want to find the slope of a vertical line, remember the slope of all vertical lines, we just say it's undefined. You can represent that by just the letter UD for undefined. Here's another example. The following data was gathered from a recent trip from Minnesota to Missouri, and there are some hours and some miles. So we want to figure out what are the dependent and independent variables. Do the number of hours you drive depend on the number of miles, or do the number of miles you cover depend on the number of hours you drive? Well, this one's a little bit confusing, but the dependent variable is the number of miles you drive. It depends, how far you drive depends on how many hours you've been driving. So time is almost always independent, as usual. And then if we want to find the slope of the line, we need to find what's changing here. So remember, we need to find out how we're getting from one point to the next one in our graph, and each of these is going up by 2. So the hours are the independent variable, so that's going up by 2. And then our dependent variables, how are those changing? How do we get from one to the other? Those are going up by 110 each time. Whoops, should be a 110 there. So to find the slope of the line, all we have to do is take the dependent change divided by the independent change, which is 110 divided by 2, which is 55 miles per hour. And letter C says, what does the slope represent in this example? Well, that represents our speed. 55 miles per hour is our speed. So here's a summary of what we learned about slope in this video. A positive slope is a line that rises from the left to the right. So as we move from the left to the right, the slope is increasing. A negative slope falls from left to right. As we move from the left to the right on our graph, it's going downward. A zero slope is a horizontal line, and an undefined slope is a vertical line. So new things that you've learned about slope, and we'll talk about those in class. See you next time.